Tesla built a 187-foot tower on Long Island with one impossible goal: power the entire world wirelessly. No cables, no plugs, just pure energy traveling through the Earth itself. His Wardenclyffe Tower wasn't just another invention. It was humanity's first attempt at planetary-scale wireless power. But here's what Tesla didn't know. Physics had other plans. The same exponential decay that kills your phone's wireless charging over a few inches would demolish his dream on a global scale. Yet modern engineers are finally cracking the code Tesla couldn't, and the breakthrough isn't what you'd expect. But before we get there, let's step back and look at Tesla's original blueprint. Tesla's blueprint was nothing short of planetary engineering. He didn't just want to power your house wirelessly, he wanted to turn the entire planet into a giant electrical circuit, with Earth itself as the conductor. This wasn't about convenience. It was about fundamentally rewiring how humanity accessed energy. Tesla's master plan for Wardenclyffe stretched far beyond that single tower on Long Island. He envisioned a network of transmission stations spanning continents, from Newfoundland to Scotland, from Colorado Springs to the European coastline. Each station would pulse electrical energy into the ground, creating a planetary grid that made traditional power lines obsolete. The audacious assumption at the heart of his design was simple but revolutionary. Tesla assumed electrical energy could pulse through the ground like blood through veins, reaching every corner of the globe with minimal loss. He imagined Earth's crust and atmosphere as perfect conductors, ready to carry massive electrical loads across thousands of miles. Ships would light up in the middle of the Atlantic Ocean, drawing power directly from the planetary grid beneath the waves. Cities would eliminate every power line, every transformer, every cable. Aircraft would pull energy straight from the atmosphere, never needing to land for fuel. Tesla's vision extended beyond pure power transmission. He planned to encode information within these electrical pulses, creating the world's first wireless internet decades before anyone understood what that meant. Messages, telegraphs, and data would ride alongside the energy waves, connecting every corner of the planet in a single integrated communication system. He calculated it would be more efficient than copper wires, believing the Earth and atmosphere would act as low-resistance conductors, an assumption later shown to be incorrect. The engineering behind Wardenclyffe reflected this planetary ambition. The 187-foot tower sat atop a 120-foot deep well, specifically designed to tap into the Earth's electrical characteristics. Tesla believed this deep grounding system would allow him to inject massive electrical currents directly into the planet's conductive layers. The tower's copper dome would simultaneously broadcast energy into the atmosphere, creating dual pathways for global power distribution. Every measurement, every specification was calculated to maximize the Earth's natural ability to carry electrical current. Tesla's confidence in this approach was absolute. He believed he had solved humanity's energy problem forever. No more coal plants, power distribution networks, or energy scarcity. The entire planet would become humanity's first wireless charging pad, delivering unlimited power to any device, anywhere, at any time. Tesla saw this not as an invention, but as the inevitable next step in human technological evolution. But Tesla's grand vision rested on assumptions about physics that would prove catastrophically wrong, the physics trap that killed a dream. Tesla's wireless power demonstrations could light up a room and create spectacular electrical arcs, but the same physics that made them possible also guaranteed his global network would fail. Those mesmerizing displays weren't just showmanship. They revealed the fundamental mechanism behind wireless power transmission. Tesla coils operate as high-voltage, high-frequency generators that create rapidly changing magnetic fields. These oscillating fields induce electrical current in nearby objects without any physical connection, lighting bulbs across the room and sending sparks dancing through the air. The magic happens through electromagnetic induction, the same principle that powers transformers and generators worldwide. When alternating current flows through the primary coil, it generates a magnetic field that expands and contracts hundreds of thousands of times per second. This changing field cuts through space, inducing voltage in any conductive material within range. Tesla's demonstrations proved this concept worked brilliantly over short distances, creating enough induced current to power light bulbs several feet away from the coil. But Tesla didn't fully grasp the fundamental limitation that would destroy his global ambitions. Field strength falls off very rapidly with distance. What lights a bulb feet away becomes negligible at longer ranges. Double the distance from a Tesla coil, and you lose roughly 6 times the power. Triple the distance, lose 14 times the power. This rapid drop-off makes long-range wireless transmission impossibly inefficient using electromagnetic induction alone. The math tells the brutal story. Tesla's demonstrations work because they operated over distances measured in feet, not miles. A bulb that glows brightly at 5 feet will barely flicker at 50. Scale that up to continental distances, and the power loss becomes astronomical. Tesla's tower would need to generate millions of times more energy than necessary just to deliver a usable amount thousands of miles away. Tesla's critical misconception ran deeper than distance limitations. Tesla assumed that Earth and air were excellent conductors. In reality, both are poor conductors, so ground-based transmission would suffer huge losses. The energy losses through ground transmission would be enormous, making his planetary grid physically impossible with available power generation technology. Tesla was working at the absolute edge of contemporary physics knowledge, building theories from brilliant intuition rather than the experimental tools that would emerge decades later. He operated in an era when electromagnetic field behavior remained poorly understood, before scientists had developed the mathematical frameworks to predict power transmission losses accurately. Modern physicists recognize that Tesla didn't know what he didn't know. His theories were based on incomplete understanding of how electromagnetic energy actually propagates through different materials. The same electromagnetic induction that made Tesla's coils spectacular also created the wall of physics that made global wireless power impossible with his approach. Yet Tesla's failed experiments laid the groundwork for wireless power solutions that actually work. From parlor tricks to pocket chargers. Your smartphone's wireless charger is a direct descendant of Tesla's coil experiments, using the exact same electromagnetic induction principle, just engineered for reality instead of dreams. Modern wireless charging borrows Tesla's induction idea, but adds resonant coupling, tuned frequencies, and precise coil geometry to make it practical. That sleek charging pad on your desk operates through identical physics to Tesla's spectacular laboratory demonstrations. A coil inside the charger generates a magnetic field that induces current in your phone's receiving coil, transferring power across the small air gap without any physical connection.